Welcome to section 2.9, Pointers. In this video, we will talk about what is a pointer, and we'll talk about declaring a pointer, initializing a pointer, talk about null pointers and how to dereference a pointer, as well as pointers and arrays. So what is a pointer? Pointer is a type of variable that can point to other types of variables. A pointer holds a memory address of another variable. When we declare a pointer, that pointer gets its own address in memory. That address is different from the address being stored inside it. To declare a pointer that points to a specific type, we declare it the same way we declare other variables, but we add an indirection operator, or a star, in front of the pointer name or the pointer identifier. So for example, if we want to declare a pointer that points to an integer, we simply say int star and then the pointer name, in this case pt. So we say the pointer pt is a pointer to an integer. To initialize a pointer, we use the ampersand operator in front of the variable whose address we want to store in the pointer. So if we have a variable called id num and it's an integer, and if we have a pointer called pt and it stores integer type addresses, if we want to assign id num's address to pt, we say pt equals ampersand id num. The ampersand indicates that we would like to store the address instead of the value, in pt. Is initialized and it's storing an address, or it's pointing to an address in memory. If we would like to access that address, either to fetch the value stored in it or to store a value in that address, we have to dereference that pointer. And to dereference that pointer simply means to access the value or to manipulate the value stored in that address, the address that the pointer is pointing to. We do that by adding the star sign in front of the pointer name or the pointer identifier. So for example, if we would like to store the number 1001 in the pointer pt, we simply say star pt equals 1001. What that does is it stores the value 1001 in the address that pt is pointing to. Let's do an example now. This is example 2.9.1. In this example, let's create an integer called a, and let's assign the value 30. Then let's create a pointer pt, and let's assign it the address of a. Then let's display the address of pt, not the address stored in pt, but rather the address of pt itself. Then let's display the address stored in pt as well as the address of a. The address of pt and the address stored in pt should be different. However, the address of pt and the address of a, they have to be the same because the address of a is stored in pt. Then let's display the value that pt is pointing to. The address or the value pt is pointing to is the value stored in a, so we should expect 30. Finally, let's use pt to change the value stored in a. Let's change it from 30 to 100, and let's display the value of a to make sure that we have actually changed that value to 100. Once you open the file, this is the code that you will see. On line 5, we declare an integer a and we assign it the value 30. And then on line 6, we declare a pointer pt and we assign it the address of variable a. We use the ampersand sign to indicate that we would like the address of variable a, not the value stored in variable a. And then on line 11, we use the printf statement to print the address of the pointer PT. The placeholder for a pointer is $p. Then on line 12, we use the printf statement to print the address stored inside the pointer PT. This address should be the address of variable A. Then, to confirm that this is actually the address of variable A, we print the address of variable A on line 13. And then on line 14, we print the value that PT is pointing to. This value should be the value stored in A. So this should give us 30. And then on line 16, we change the value stored in A using the pointer. So star PT equals 100 will store the value 100 in the variable A. Then on line 17, we confirm that the value stored in A has actually changed. Let's compile and run. So we're going to come to build right here. Everything looks okay. Let's run the code. And here we have the address of PT is 0061FF08. This is a hexadecimal number representing the address of the pointer P. And then we have the address stored in PT inside the pointer is 001FF0C. Again, this is a hexadecimal number, but this time it's representing the address stored inside P. And this should be the address of the variable A. And to check that this is actually the address of the variable A, we print the address of the variable A, and it is the same. This is what we are expecting. And now, on this line, we print the value that PT is pointing to. This value is stored in A. PT is just pointing to that value. It's 30, and that's what we expect, because over here we stored the number 30 in the variable A. And then finally we used PT on line 16 here to store the number 100 in the variable A, and then we printed the value, the new value of variable A, and indeed the value of A is now 100. That's what we expect. Okay, so let's go back to our slides now. Next is null pointers. So if you declare a pointer but you don't want to assign it a value or an address right away, it would be a good idea to initialize it to null. Null means it's pointing to nothing, and we do that by saying int if it's a pointer that's pointing to an integer. So we say int star PT equals null, and the pointer that is initialized to null is simply called a null pointer. By doing so, you're explicitly saying that this pointer is pointing to nothing. We do that because sometimes the pointer might contain some garbage value, some garbage address, and by initializing the pointer to null, you're saying that this pointer is really pointing to nothing. The last topic for this video is pointers and arrays. Pointers and arrays are related because an array is really a pointer that points to the address or to the memory address of the first element in that array. So if we have an array of 5 integers called num, so int num with a size of 5, num is the name of that array. It's the identifier of that array, and it is considered a constant pointer. This constant pointer points or stores the address of the first element in that array, which is num with the index of 0. And I say constant pointer because this pointer always points to that same address. It cannot be changed. This is unlike regular pointers, which can be incremented or decremented to point to different addresses. Now let's do another example. Please open File, example-2-9-2.c in code blocks. Once you open the file, this is the code that you will see. I did not include a description of this example in the slides. It's just because it's a little bit longer. So in this example, what we're going to do is we're going to declare an array of integers, of 5 integers, and we're going to call it id underscore nums, and we will initialize this address with these values, with these 5 values, 1, 2, 3, 4, and 5. And next we will declare a pointer pt, and we will assign it the address of the first element of the array id nums. Next is print in some addresses just like the previous example. So the first 2 addresses is the address of the pointer pt, and the second address is the address stored inside the pointer pt. Then next we will print the address of the identifier id nums, or the address of the array, and we will print the address of the first element in that array. We should expect that the address of the array id nums and the address of the first element in that array to be the same. If you remember, I mentioned in the slides that the name of the array, or the identifier of an array, is nothing but a pointer, a constant pointer that points to the first element, or to the address of the first element in that array. So in fact, this address, which is the address of the first element in that array, and the address of the array itself, or the array name, and the address stored in the pointer pt are all the same address. We should expect them to be the same address. And next we will print the value that pt is pointing to, and we should expect this value to be 1. That's because on line 6 we assigned the address of the first element, which has the value of 1, to pt. I also mentioned in the slides that we can increment and decrement a pointer, a regular pointer, to point to other addresses. So on line 14 to 16, I'm going to demonstrate that. We can make a pointer point to another address simply by adding or subtracting an integer, a whole number, and by doing that we are telling it to move a certain number of positions. So in this case, on line 14, we're saying pointer equals to pointer plus 3. So we're asking the pointer to move 3 positions to the right. So right now it's pointing to the first element of the array id nums, and by adding 3 to it, we're asking it to move to the 4th element of that array, or to point to the 4th element in that array. And then after that, on line 15 and 16, we will validate that the pointer is now indeed pointing to the 4th element. So we print the address of the 4th element on line 15, and we will print the value that the pointer pt is pointing to on line 16. This value should be the same value of the 4th element in the array id nums, so we should expect that value to be 4. Next, On line 18, we are doing some more pointer arithmetic, and we're saying PT minus minus. PT minus minus is similar to, same as, move the circle here, PT equals PT minus 1. So PT minus minus is similar to, or is the same as, PT equals PT minus 1. Similarly, if we had said PT plus plus, so if we wanted to increment the pointer by 1, so we would say PT plus plus, and it would be the same as PT equals PT plus 1. In this case, we are decrementing the pointer PT by 1. And so since we had moved the pointer to position 4 on line 14, and now we are moving the pointer backward by 1 position, so now we should expect the pointer to be pointing to the third element of the array ID nums. In other words, this address that's going to be printed here has to be the address of the third element of the array ID nums, and the value that PT is now pointing to has to be 3, the third element. Next, we will use the pointer PT to change the value in that third element, and we're going to change it from 3 to 88, and then we will print the value stored in the third element ID nums, which has an index of 2, and we're going to check that we indeed were successful in changing the value from 3 to 88. And finally, on line 25, I'm going to try and see what happens if I try to increment the name of the array ID nums. We should expect an error when we compile the code. And so let's try and compile. And indeed, we have an error. And it's pointing us to line 25. That's because, like I said in the slides, an array name is a constant pointer. It cannot point to any other address other than the first element, other than the address of the first element in that array. So I'm gonna comment this line out, and I'm gonna try and compile again. And this time we have no errors. So let's run the code. Okay, so first line says the address of PT is 0061 FEF8. The address stored in PT is 0061 FEFC. So the address of the pointer is different from the address stored inside that pointer. And next, we are printing the address of ID nums, the address of the array. And as we expect, this address is the same as this address because PT is pointing to the first element of the array ID nums. And again, the address of the first element in ID nums is indeed, in fact, the same address as the address of the array, and it's the same address as the address stored in PT. And then after that, we are printing the value that PT is pointing to, and since it's pointing to the first element of the array ID nums, this value is 1. Then after that we move the pointer 3 positions to the right. And so here it says after moving 3 indexes forward to the 4th element, the address stored in PT is now 0061 61FF08. And the value of that address is 4, just as expected. And then after that, we move the pointer one position or one index backward to the third element, and as you can see, the address changed again. And now the value that PT is pointing to is 3, just as expected. And then finally, on line 22, we use the pointer to change the value stored in the third element to 88, and that's exactly what we did here. And the message is saying the value stored in the third element of ID nums is now 88. That's because we changed it on line 22. And now let's go back to the slides. And with that, we come to the end of this video. The next video is section 2.10, and we're going to talk about functions.